into evaluating limits numerically. This is part B. For the first section, we did graphically. Now we're going to do numerically, which is just basically finding the limit, but only using a table of values because we don't have the graph. This can be time consuming, but you don't always have to do a whole bunch of these problems. You just have to learn how to do it, and then you will get the random problem here and there, basically. So to start off, estimating numerically means that you're going to make a table of values. And you're going to analyze them to see what is the behavior of the function as it gets nearer to the given x value. So example 1, here's a table. It is completely filled out. Estimate the limit using the given table. So the idea would be we want to figure out what is the limit of this function as x is getting closer and closer to the number 0. Now, if you observe, here's my number 0. And then that's why the question mark is there, because we don't know what it actually equals or what it's getting close to. We're trying to figure that out. Now, from the left, right, as I approach from the left, the x values that were chosen are negative, which makes sense because to the left of 0 are negative numbers. But look at these numbers. They're really, really small. Like, they're really, really close to 0. I mean, if I were to round this first number to one decimal place, to the tenths place, it would be 0. Negative 0.01. And then the following one is even smaller. Okay, and now that's the idea. You want the numbers to be super close to the x value, but not exactly the number itself, because then for most of the problems it won't work. But just close enough so that you can get an idea of what's happening. Now from the left again, if you look at the y values, right? These are the y values. It starts with 1.99 and then 1.999 and then 1.99995. Like, what is happening? You know, as we move along here, these numbers are increasing. It must be like they all look the same. Well, if you look at the last three, they do make a difference. Okay, 499, 950, 995. They're increasing. I didn't deal with the first three numbers because they're all the same, 1.99. So it's increasing. I'm not saying it's increasing a whole bunch, but it's increasing. Now, what number would this appear to be headed towards? Hopefully, in your mind, you're thinking, oh, well, it looks like it's heading towards 2, right? Okay, so the limit as x approaches 0 from the negative side of f of x sure looks like it's headed towards 2. Now, for the right side, so as I move along here, once again, the numbers are pretty close to 0. As I travel, right, from the right, what seems to be happening to these numbers? So again, I'm going to focus on the last three numbers. Now these numbers aren't increasing, they're getting smaller. As I travel towards the 0, these numbers are decreasing, right? If I start with 499, I end up at 50 and then 5. They're getting smaller, but nonetheless, what number are they approaching? What is my limit as x of f of x as x approaches 0 from the right side, the positive side? And hopefully you're going to tell me 2. So what is the overall limit here? What is the limit of this function? And hopefully you're like, oh, this should be 2. And that's what this entire section is. Okay, so for the next two examples, I'm going to give you the x values. The idea is that you'd be able to find the y values, and you would just do that by plugging into the equation, right? Here's the equation. Voila. Oh, here's the equation. No big deal. we would plug in every single one of these into the equation, and then we would have our y value, and then we'd analyze the table. So for example 2 and 3, I'm going to give you the x values. For example 4 and 5, um, the table is completely empty. So now, before I start, I do have all the values already, so we're not going to waste time on that. But when you do have a table, you want to have an idea of where the number that you're working with is, where it should be. See, this is an already made table, and where x is approaching 4. Okay, well, where's 4 supposed to be in this table? And right here, this is where x equals... I'm trying to write with a highlighter, and it's not really working out so well. Okay, done, done, and done. Haha! Alright, so now that I know where it is, I know where my left and my right is, and I can figure out my y values. Alright, so here are my values, and I would have gotten these just by plugging in my x's. So, let's analyze from the left. So from the left, so as I come this way, what are happening to my numbers? So let's see, the first two are all the same, and this is a decimal, obviously. So 408, 40, and 4. They're decreasing. But the numbers appear to be getting closer and closer to 0.200. Okay, so from the right side, let's see, first two numbers are the same, so these numbers appear to be increasing. So on the left we were decreasing, on the right we're increasing, but again, the number that both sides seem to be approaching is 0.200. So my limit is going to be 0.200, or 1/5. Example 3, I'm going to do the same thing. Alright, so I figured out where my x value should be, x equals 0. I highlighted it. I figured out my y values, and now to analyze. See, 50, 42, 41. So it's decreasing. And then from the right, 33, 40, and 41 increasing. But oh, look at that. They're the exact same number. The left and the right are literally 0.2041, the same number. So my limit is 0.2041. So example 4, this is the first example where the entire table is blank. Now, whenever you are given a blank table, you are allowed to pick whatever x values you see fit. So I'm going to pick some x values, but yours could be different if you chose them to be. Okay, so if I observe, my x is 0. So let's say that this right here, this is where x equals 0 should be. So that means I'm going to have to pick numbers a little slightly bigger than 0 and slightly smaller than 0. So the slightly smaller than 0 should be negative, right? And I'm just going to be, let's see, I'm going to put 0.001 and then 0.01. And then for the positives, I'll just use the same numbers, which is positive. And so now the idea would be that I would plug these into the actual function. This is probably an example where you'd be better off using a calculator to plug in. And then I also have to pay attention to the fact that, oh look, this is just in case, of course, you don't pay attention to the fact that, oh looky, looky, you see that plus? I'm only really interested in the right-handed limit. I only want a one-sided limit. Alright, so I plugged in my values, and hopefully you're like, oh, I see. But for the right the limit is just 1. Um, if we were looking for the overall limit, then it'd just be 1 on both sides, right? It's 1. But we're looking for the right-hand limit. Sometimes you have to do that even with a table of a table of values. All right, example 5. If you have an early copy of the notes, then this right here needs to be fixed. I left out the x equals 3 part. So here we're determining the one-sided limits numerically, and then tell whether the two-sided limit exists. So basically, what we have been doing, you have to pick values close to 3 on both sides of 3. I'm just going to go ahead and fill this one out a little differently, kind of like the one at the very beginning. Here's 3, and I don't know what my limit is, but I have to pick values slightly bigger and slightly smaller. Right? The slightly bigger and smaller, they're getting me close enough to 3 that I can figure out what the graph is without actually using 3. Now you must be wondering, why? And the reason is very simple. Looking at this equation, if I were to plug in 3 squared, and then 3 squared minus 9, I would get 9 over 9 minus 9, which is 9 over 0. And hopefully you know from experience that you never divide by 0. That's a no-no. Okay, so I'm going to choose some values, and I'm just going to, let's see, 2.99, but then 2.999. That's slightly closer to 3. And then 3.001, and then 3.01. So I plug those in, ideally, right? And I get some numbers. Alright, so I plugged in my values, and from the left, I see that I have negative 149, but then I end up with negative 1,499. So these negative numbers are decreasing significantly. Now don't get confused. Remember, negative numbers, the bigger or the smaller they actually are. So decreasing significantly. And when this happens, significantly, oh my goodness. When this happens, this is an indicator that this function is actually headed towards infinity. And in this case, since it's decreasing, it's going towards negative infinity. So it is safe to say that the limit as x approaches of f of x as x approaches 3 from the left side is negative infinity. Now for the right, as I go this way, well, I have 150, but then I have 1,500. So it's also significantly changing, but it's just increasing. So it is increasing significantly. And this is an indicator that it's actually headed towards positive infinity. So the limit of f of x as x approaches 3 from the positive side is positive infinity. Well, by now you should know that that means that my answer is the limit does not exist. Answer the practice problems.